So here we have our rock wall, which represents geological structures and well bores. And specifically, this is a vertical well bore. Obviously, it's straight up and down as opposed to horizontal wells. These were the initial wells drilled in oil fields. They usually drill down to the very top of the reservoir, which my hand is on the reservoir. And usually in those reservoirs, you had oil on top of water. So typically, we'd only drill into the very top of the reservoir and complete there. The little bars represent what we call perforations, where we take guns and actually shoot holes through the pipe and out into the formation, and then the oil comes through those perforations into the wellbore. It is produced to the surface. In the 1980s, they started producing from a reservoir in South Texas called the Austin Chalk. It is a chalky limestone. It is soluble with acid. Initially, they were drilling vertical wells, and the target was the Austin Chalk very close to a fault where you have slippage of one rock relative to the other. Where you would have that slippage along the fault plane, the rock would crack up. We call that naturally fractured. So this is to represent the Austin Chalk, this tan formation here. And you can see here is a fault where this side has slid down the fault plane relative to this side. So up where the Austin Chalk is close to this fault plane is where you have the breakage of the rock. That is where we find the rock is productive. So if you drill a well, vertical well, intersect those fractures, you have a nice well making 100 barrels plus per day. If you miss those fractures with a vertical well, you'd only have a well that would make just a few barrels a day. So to make it easier, it was very difficult to drill vertically and actually hit those fractures. They started drilling horizontal wells that were perpendicular to the fault plane, so they couldn't help but intersect those fault planes and those natural fractures. Later on, we started drilling wells horizontally in our shale formations. Those shale formations were a little bit softer and not maybe as brittle as our Austin Chalk. And the fractures we had, or the natural or existing fractures, were very few and not very effective. So we basically, here Mother Nature has hydraulically fractured the wells for us. Over here we have to help Mother Nature hydraulically fracture. So this is where you see us, after drilling the horizontal wells, hydraulically fracturing the entire length. The other difference is these wells over here were only just a few thousand feet, or a couple thousand feet, or maybe just 1,000 feet in length, where we're drilling these horizontal wells nowadays 3 and 4 miles long. Now, the reason why we make lots of water with these wells is that when we create these natural fractures in the rock, the water and oil coexist. So when you produce the oil, you're producing the water at the same time. And so you see that with a 4-mile lateral, 4 miles long, that's a lot of surface area to produce lots of water. And we produce roughly 2 to 6 times the amount of water as we do relative to oil.